1927 is when the world hit 2 billion in population. And just less than 100 years later, you were at 7 billion. It puts a tremendous strain and a tremendous demand on infrastructure to deal with that population growth. We have to innovate our way. We have to use disruptive technology in order to make it less expensive to expand our infrastructure and deal with the growth of the human race.
The reality is that the way we used to build infrastructure, that'll have to change, and it is changing. We have new technologies, we have huge amounts of digital systems which enable us to reduce the cost of not only the design process but also the construction process. In London, very recently, there was a building that was built using a lot of prefabrication. One of the big advantages there was rather than having 600 people on site, you only had to have 200 people on site. Now, a third of the people means you're probably going to have a third of the accidents. There's going to be a lot fewer people in harm's way. And that safety is a real driver for the use of digital systems.
With the example of the Great Wall project that we did, there's this one section of the wall called the GN Cow where it was really hard to reach. So with the Intel Falcon 8 Plus drone, what we did is we took thousands of high-resolution images. We were able to take that information, process it into a 3D digital model, and just visually inspect the wall without endangering human lives.
I was doing a study on machine control and the equipment, and I was interviewing the drivers of this 3D machine control, and I asked them what the benefits are. So they went through the usual, the accuracy, the efficiency, all the things we expect with digital technology. However, what struck me is when he talked about fatigue, and he said that actually using these machines is less fatigued for a 50-year-old driver. So he said to me that actually when he goes home on a night, he knows he's got a job well done, the efficiency's up, he's hit his targets, and he doesn't have to worry about the accuracy. To turn that into an analogy that somebody that doesn't know 3D machine control, imagine you're in a car and you're on a long drive and you put cruise control on. It's as simple as that.
If you look back to automation in a machine shop, the big invention, a big step function change back in the 50s, 60s, we ended up having what they call CNC machines. They said, hey, if I could put the measurement instruments on the machine, then I could have an operator set up a machine and then machine the same thing over and over and over again, very precisely. Well, think about in the construction business, Topcon made the measurement instruments. The measurement instruments had to be connected to the machines. The machine, I see a bulldozer, an excavator, a loader, any of the machines that are on a job site, they look like a mill or a lathe to me. We're just machining the face of the earth.
All of this is leading towards an environment where machines can go out and perform these tasks. And you can't get there without having all of the intelligence required to do that.
You don't do that just as a vendor, you do that as a partner with other customers and partners who have a deep expertise.
The technology that is available today that wasn't available even 5 years ago is so revolutionary to what it is that we're trying to accomplish that every day you get up, if you're not excited about this business, and what we can change, we're changing the way people are building infrastructure in the world.